Hi there. Welcome to this practice set for dividing radicals. Please like and subscribe if you find this practice set helpful. Drop a comment or ask a question below and check out the many other videos and playlists on the channel. See my other videos on adding and subtracting radicals and multiplying radicals if this practice set does not actually align with the information that you are looking for. I'll link them in the description and they can be found on the radicals playlist. Please pause the video to work these problems on your own and then come back to check your work. Okay, let's get to going over these. In number one, we have 5 divided by the square root of 5. And of course, we want to rationalize that denominator. We cannot divide by that square root. And to undo the square root, we will square it. And we're not going to write it as squaring because that obscures what we're trying to do. Instead of writing it as squaring, we're going to write it as times itself. And what that does is it makes it visible that what we are multiplying by is equal to 1. In the numerator, we'll have 5 root 5. Okay, and in the denominator, the square root of 5 times square root of 5, you can write the square root of 25, or you can recognize that that is just a 5. Oh, look at this. Oh, this is cool. 5 divided by 5 is 1. And so that leaves us with the square root of 5. So 5 divided by the square root of 5 is just the square root of 5. There are other ways you could reason that out as well. Okay, for the next one, we have the square root of 3 divided by the square root of 6. So using the same reasoning, we're going to multiply by the square root of 6 over the square root of 6, which of course is equal to 1. This will give us the square root of 18, and you can go straight to the 6, okay? That would be fine. Or if you want to just see more of the work, that would be the square root of 36, which is 6. Now here, we do have to simplify this, okay? The square root of 18. So I'll do a little bit of scratch work, and you can simplify that however you want, all right? So that factors into 9 times 2, 9 factors into 3 times 3. And so this will be the square root of 3 times 3 times 2. And because it is a square root, we're going to home in on that pair, which will give us 3 root 2 over 6. And now right here, 3 over 6 is equal to 1/2. And so we would have 1 square root 2 over 2. You can put the 1 there if you want, so you can actually see the 1/2, or you can just write root 2 over 2. So there we go on those first 2. Moving on. Yeah, lovely ones. Okay, well they start out like, okay, I did put these in order from least annoying to most annoying. Which is kind of how I feel about them. Like, these are just kind of annoying. All right, so when we have the yuckier denominator, our trick to get rid of the radical in that denominator is to multiply by the conjugate. And as before, you got to multiply by the number 1. We want the fraction that we get at the end to be the equivalent value of the fraction that we had at the beginning. Now you might want to do some scratch work here. So in my numerator, I'm going to have the square root of, 5 times 2 minus root 7. So that'll be 10 minus 5 root 7. 10 minus 5 root 7. And then my conjugates will have 2 root 7 times 2 minus root 7. So 2 plus root 7 times 2 minus root 7. We have 4 plus 2 root 7 minus 2 root 7 minus the square root of 49, or you can go straight to the 7 on that. So we're going to have 4 minus the square root of 49, or 4 minus 7, which is -3. And then I'm going to leave the answer right there because I don't think there's much productive we can do with that. We could maybe split up the fractions a little bit. That's kind of up to you whether or not you think that is a valuable step to take. Okay, next one, we have the square root of 6 over 3 plus root 2. So our strategy, as always here, is to multiply by the conjugate of the denominator. My numerator is going to look like this, root 6 times 3 minus root 2. So that will give me 3 root 6 minus root 12, which does simplify. 12 will factor into 4 times 3. So we'll have 3 root 6. The square root of 4 is 2. And we end up with that. So we end up with 3 root 6 minus 2 root 3. So much fun. All right. And my denominator should be a little bit nicer as a final product. So we have 3 times 3 is 9, plus 3 root 2 minus 3 root 2 minus root 4. So that'll be 9 minus the square root of 4, or 9 minus 2, which is 7. Oh, beautiful things. And I mentioned earlier, you can probably hear a little bit of sarcasm in my voice for what it's worth. Just like, do I personally find problems like this a nuisance? Yes. And some of that goes to like how I am hardwired to do math. I can do them. I teach them. I understand the rationale behind why we do these, but like, are they kind of annoying? Yeah. Okay. All right. So now we get to even messier ones. So I know everybody watching this video is thrilled with that. And what I'll try to do here is abbreviate some of my scratch work. So we've got the conjugates. So we're going to be multiplying by the conjugate of the denominator. And you kind of hope that it's going to come out like okay-ish. So let's see what we have going on. I have 3 plus root 5 times 2 plus root 3. So that's 6 plus 2 root 5 plus 3 root 3 plus 15 root 15. That looks actually pretty promising in that there really is not anything we can simplify, which that's where it really starts getting super annoying, is when you've got all this simplification you can do, but we've got a lot of prime numbers going on there. So not, if this were a number that problem that had like 6s and 8s and 10s and stuff in it, all those 2s would start to multiply together and you'd have more simplification work, but we're not needing to deal with that. All right, and then let's look at this. So we have 2 minus root 3 and 2 plus root 3. And what you might do is you might say, hey, I know those are canceling out anyway, so I'm not even going to bother to look at them, that you really care that it's -2 root 3 and 2 root 3, because they're going to cancel out. Save yourself some time. This will be negative root 9. And so we'll have 4 minus the square root of 9, or 4 minus 3, or 1, which is nice. Now, looking at my answer over here, do I really need to divide something by a 1? No. And so I'm going to go ahead and just do away with that. Like, there was just no reason to write divided by 1. So there we go. Denominator rationalized. Okay, and then we have 2 plus root 7 over 3 plus root 7. Now, you might be tempted to say, well, can't we cancel out the root 7s and just say that's equal to 2/3? It would be so nice and convenient if that's how numbers in math worked, but it is not how numbers in math work. So we've got to go through that, multiply by the conjugate. If there were a shorter way to do this, I would be the first person on board with it. So we have 2 root 7 and then 3 minus root 7. So we have 6. This is 3 root 7. This is negative 2 root 7. We're going to be able to do some stuff there. Minus root 49. So I'm going to go ahead and write that right there. And minus the square root of 49. We'll go ahead and write it. Now, right here, 3 root 7 minus 2 root 7 is 1 root 7 or just root 7. And if you're like, well, what does she do there? You want to go back and check out my video on adding and subtracting the radicals, because we would cover that there. Minus the 7, and so 6 minus 7 is negative 1, and so that lovely thing ends up being negative 1 plus root 7. So happy and excited about that. It's not really. Okay, 3 root 7 and 3 minus root 7. So we've got the 9, and then again, if you just want to take that shortcut and say, hey, those are canceling out anyway. But if you really want to, we got the, that'll be 3 root 7 and negative 3 root 7. So go us. This ends up being 9 minus the square root of 49, or 9 minus 7, which is 2. And that one actually simplified really, really nicely. But notice that it is not actually equal to 2/3. Okay, like those are not the same thing. So no, you cannot just cancel out the square roots of 7. So if you tried to do that, kudos to you for looking for some stuff to make some math connections. But in this case, it does not actually connect. You've got to go through that process of multiplying by those conjugates. Now, the last two, I opted to throw in some complex numbers just for review. Now, you might be doing this if you were doing rationalizing the denominator as part of an Algebra 1 course, then when you got to these, you probably had to stop. Just say, I do not know what those are. If you're doing it as part of an Algebra 2 class, probably you have already covered these kinds of numbers before you got to radicals, although maybe not. So if this does not apply to you, if you're like, I have never seen that little I in my life, no one has ever taught that to me, I don't think I'm in the right class for that, you go ahead and end the video. Just don't forget to like it. Okay. And now, but if you have covered these, these kinds of numbers, this is a good review of what we need to do. But essentially, those i's are radicals. And so we treat this exactly the same way we treat like visible square roots. We're going to multiply by the conjugate. And so we're going to have our scratch work off to the side. And plus 6i, so we have 3, we have 5i, we have 18i, and we have 30i squared. Then 5i plus 18i, well, I'm going to go ahead and write it out, plus 30i squared. So this is 23i, but we want to remember that I squared is equal to negative 1. Which means that we have a negative 30 there, and 3 minus 30 is negative 27. And so my numerator ends up being negative 27 plus 23i. My denominator will be much nicer because the denominator we picked in order to get stuff to cancel. So we'll have 1 times 1 is 1. Negative 6i, positive 6i, and negative 36i squared. And so those cancel. Love those conjugates. So we end up with that, but I squared is negative 1. So that is negative 36 times negative 1, which is positive 36, which means that all simplifies to 37. And we have rationalized the denominator of our complex numbers. Again, I just can't hide. I can't be all excited about this and say, like, what a wonderful kind of problem this is. That yes, there's quite a bit of scratch work. The better you are at this, the more space you can save with that scratch work. But like, yeah, you're just going to have to push on through that. Yeah, it's a lot of fun. Okay, last one will not be as bad. I think that last one took the cake there. Now, with this one, I've had a lot of students say to me, well, like, why, like, there's no conjugate, like, what should I do with this? And we've talked about, well, 3i is really like 0 plus 3i, like the real component would be a 0. I've had students say, well, I would square a square root, so I would just multiply by 3i, or maybe multiply by negative 3i. A lot of those would work, but the fastest way to do this one is simply to multiply by the I over I, is really the simplest way to do that. I over I is 1. That has not changed. And so in our numerator, we have 6i. In the denominator, we have 3i squared. But we remember that I squared is equal to negative 1. And so that becomes 6i over negative 3. And then 6 divided by negative 3 is negative 2. And so 6 divided by 3i is equal to negative 2i. Maybe you saw that coming, maybe you did not, but there you go. Okay, so that was a lot of fun. Please don't forget to like and subscribe if you found this practice set helpful. Helpful, like maybe not the same as entertaining or wonderful or the most like thrilling 16 minutes that you have spent online watching video this week, but helpful anyway. Engage by dropping a comment or a question, and check out the many other videos and playlists that are on the channel. And if you are looking for something and you don't see what you want, please leave a comment, let me know, and I will do everything I can to help you out. I hope to see you in a future video.